Already we have covered the introduction, then different type of unknown system, then dyne system, and also we have covered various type of examples which are related to the unknown and dyne system. Now the next part is the important part once again from UV visible spectroscopy. What is that part? Is the application of UV spectroscopy, and second part is color and its complementary color. One can say that color and visible spectrum. So first point we will discuss here, color and visible spectrum. Now in this case, what we have to remember, human eye responds to only a very small region of very broad invisible electromagnetic spectrum, wavelength
Electromagnetic spectrum
400 to 800 nanometer, called as visible region. Color of rainbow, you know that ROY GBIV. It means that red, orange, yellow, green, blue, indigo red, indigo, then violet. While see here, when our eye is concerned, which things are visible by our open eye? Our open eye only see the things or light which having the wavelength 400 to 800 nanometer. If wavelength is beyond that region or below that region, our human eye will not be identify any object. For example, when we look at the nature, you'll observe that so many things, very good things you can observe, because that observed 400 to 800 nanometer wavelength light. But if you look at the nanomaterials or nanoparticle which are spread in the environment, one cannot see that nanomaterial, because that absorption region of that nanomaterials is different. It is not the region of 400 to 800 nanometer. That's why we can't see the materials which are very small in nature, or the material which absorb the light other than 800 to 400 to 800 nanometers. So remember, this is very interesting things. Now look at this. When white light falls on the object, it may be totally reflected and substance appear white. It means that when we are having the summer season, in that summer season, we always wear white clothes. Why? Because in summer season we are having lot of heat and we try to save ourselves from the heat. Therefore, we wear the white clothes. What is the reason behind to wear the white clothes? Because when light falls on that white material or clothes, all light are get totally reflected. It means that light is not absorbed that by particular white clothes. Therefore, we get the protection from the heat or sunlight. And when any object, when light is fall on that object, and if that light is totally reflected, then that substance appear as a white. Remember this one. When white light falls on the subject, it may be totally absorbed all the radiation, it appears as a black. It means that when light is absorbed on the object, any light, light when absorb, fall on the subject, what will happen? In first case, what we have seen, white light is totally reflected, therefore object appears at white. But when white light fall on the object and it is totally absorbed all radiation, then that it appears as a black. Now see students here, two different phenomena are there. Once दोन गोष्टी तिथं, एक व्हाईट लाईट ज्या वेळेस एखाद्या ऑब्जेक्ट वरती पडते आणि ती व्हाईट लाईट ज्या वेळेस सगळेचे सगळे रेडिएशन तो ऑब्जेक्ट रिफ्लेक्ट करतो, त्यावेळेस तो जो ऑब्जेक्ट आहे ते आपल्याला व्हाईट दिसतं. दुसरा भाग याच्या मधला, ज्यावेळेस व्हाईट लाईट एखाद्या ऑब्जेक्ट वरती पडते आणि सगळेचे सगळे व्हाईट रेडिएशन ऑब्झर्व करून घेतले जातात, नो रिफ्लेक्शन, त्यावेळेस त्याला तो जो ऑब्जेक्ट आहे इट इज अपियर अस ब्लॅक. म्हणजेच काय, when we wear the white clothes we do not have a lot of heat, or we do not have a unhealthy situation when summer season is there. But when we wear the black clothes, definitely we got hotter and hotter, because the white light which are coming from the sunlight, it is totally absorbed by the object, and means heat is totally absorbed. Once heat is absorbed, definitely the object become heat, or it get the heat. Therefore white clothes are suitable in the summer season, while black clothes are not suitable in the summer season. Sorry. Now see the next. When molecule absorb only a part of visible light radiation and reflect the remaining ones, it is appear to be colored. It means that when sunlight, that is 7 rainbow colors, falls on that any visible light, then particular part of light is absorbed, and that complementary color of that light is showing a color, and we appears that object in the different color. When the object absorb all but blue color, when it will appears blue, it will also appears blue when it absorb orange color. It is the complementary color of blue. It means that when blue color is absorbed by that particular object from the radiation or from the rainbow color, that color is appears at a orange color. It is means that the complementary color of blue is orange red. So remember here, I can show it very well with the help of different color. It is well known to you. It is the rainbow color, how shades are developed. See there, 1, 2, 3, 4, 5, 6, 7. There are 7 colors, and this is the spectrum of visible light. In this visible light, in the electromagnetic radiation, in the visible light, we have this different colors. Now, when actually rainbow is appears, you might have seen that kind of picture when rainy season is there, right? And it looks very beautiful. Look at this another picture of 7 color, or you can say the rainbow. So this is the rainbow's color, and look at the complementary color. This is again important part. Complementary colors means what? Look at this. So this is the object. This is the object. When that object absorb green color, that absorb green color, it appears as a red. Means एखाद्या ऑब्जेक्ट न, एखाद्या मटेरियल न विजिबल लाईट मधला ग्रीन कलर जर ऑब्झर्व करून घेतला, तर त्याचा जो कॉम्प्लिमेंटरी कलर आहे इट इज रेड. सपोज सम ऑब्जेक्ट ऑब्झर्व ब्लू कलर, its complementary color is, sorry, or yes, complementary color is yellow. When any object absorb orange color, its complementary color is blue. So see here how it is actually different. So violet color, it is turned to the blue, yellow color, means violet color when it is absorbed by that particular material or object, it appears as a appears as a red. But when that object absorb orange color, it appears as a blue. म्हणजे एक कलर अब्सॉर्ब करून घेतला जातो आणि त्याचा कॉम्प्लिमेंटरी कलर आपल्याला दिसत असतो. जो कलर अब्सॉर्ब करून घेतलेला आहे त्या पर्टिक्युलर ऑब्जेक्टनं, तो कलर आपल्याला दिसत नाही, त्याचा कॉम्प्लिमेंटरी कलर दिसतो. नाउ सी हियर complementary colors, lambda in nanometer absorb, then color absorb, color visualization or transmitted, and it is complementary color. When we have this kind of nanometers, means wavelength 400 to 435, then if violet color is absorbed, you are getting yellow or green colors. When we have this 435 to 480, blue color absorbed, its complementary color is yellow. When 480 to 490 wavelength is absorbed by that particular object or subject, it means that green or blue color is absorbed, its complementary color is orange. 490 to 500, blue color is absorbed, ultimately red color is appear. 500 to 560 nanometer, green color absorbed, its color is purple color. Then 560 to 580, yellow green absorb, its complementary color is violet. 580 to 595, yellow color is absorbed by the object or subject, then blue color is appears. 595 to 605, orange color is absorbed by that particular object, it's appear green blue. And finally 605 to 750, when red color is absorbed by the object, it appears as a blue green. It means that see this absorption region is different. Absorption of color by the objects are different, and their complementary colors are different. Means those objects who absorb violet color, it will not appear as violet, it appears as a yellow or green. Those objects who absorb blue light, its complementary light is yellow. So likewise, the material which absorb the light, definitely we appear the complementary color of that light. This is very good things to know you. Now the next part is application of UV spectroscopy. And this is the final part or last part of the topic. Application of UV spectroscopy. Why we have to study this UV spectroscopy? Because one is that one can understood the extended conjugation. Extended conjugation means what? How many double bonds, extra double bonds are present in the compound. That can be identified by making use of UV spectroscopy. See this example. CS2 double bond CS single bond CS2 single bond CS2 single bond CH double bond CS2. In this compound, look at this, 6 carbons are there and 2 double bonds are there. These 2 double bonds are away from each other. They are not conjugated way. They are not adjacent to each other. They are far away from each other. In this case, this compound containing 2 double bonds and they are far away from each other. Therefore, it is called as non-conjugated system or isolated system. In this case, we don't record the UV spectrum or especially lambda max of this compound. And whatever we got that lambda max, it is only 175 nanometer. If you look at another side, same compound that we have taken, but we have changed the carbon-carbon double bond position. In the second compound or second example, two double bonds are conjugated in manner. They are not isolated. They are not cumulative. They are in alternate situation, or they are in conjugation situation. So therefore, so we will